Welcome back to The Explainer. Today, we're literally pulling back the curtain on the ultimate black box of our modern era, generative AI. We're going to trace the spark of this technology all the way from a single, surprisingly simple math equation right up to the massive societal shifts happening across the globe. It's a pretty wild ride, so let's just get right into it.
To really grasp why this tech is such a massive game changer, we kind of have to look at just how insanely convincing it's become. Take 2021, for example. A Google engineer named Blake Lemoine was testing an AI model called LaMDA. He was having these totally free-flowing conversations with it, and the AI's responses were so nuanced, so incredibly human-like, that it completely blew his mind. He actually went public claiming he believed the system was sentient. Now, he was ultimately fired, and Google maintained the AI was just exceptionally good at pattern recognition. But it forces us to ask, just how powerful are the models running beneath the surface?
So here's our roadmap for this explainer. We're going to break down exactly how this sentient-seeming technology actually operates. We'll start with the neural network foundation, peek inside the famous transformer engine, talk about controlling the output, see the stuff in practice, and finally look at the risks, bias, and ethics. And hey, don't sweat the math. We're going to keep it crystal clear. All right, let's jump right into section 1, the neural network foundation. Basically, how do we actually build an artificial brain? Okay, so the foundational building block here is the artificial neuron. Think of it as just a mathematical function. It takes an input, turns the dials on specific parameters, which we call weights and biases, and generates an output. But to handle complex, messy real-world data, the neuron uses an activation function, like the sigmoid function, to bend and shape that data. This is what lets the network make complex, nuanced predictions, instead of just drawing rigid straight lines. Now, a great way to visualize this entire training process is to picture a factory assembly line. Step 1, forward propagation, is your factory floor, where data moves through layers of neurons to produce a prediction. Step 2, the cost function, is your quality inspector, checking exactly how far off that prediction is from the actual truth. And then the real magic happens in step 3, back propagation. This acts as the factory manager, automatically sending instructions backwards through the line to tweak those weights and biases so the next prediction is just a little bit sharper. So, that factory setup gives us a standard neural network. But what actually gave us generative AI? Well, that brings us to section 2, inside the transformer engine. This is the 2017 architectural breakthrough that literally changed the game. Before we get into the nuts and bolts, think about this. How does a machine actually understand context? How does it know that the word bark means a tree covering in one sentence, but a dog's noise in another? Well, it all starts with embeddings. Because, an AI doesn't read letters like you and I do. When you type a prompt, it's broken down into tokens and converted into numerical vectors, or embeddings. The AI is literally mapping out the semantic meaning of your words in this vast mathematical space, adding positional tags so it never loses track of the word order. And that brings us to the real magic, the multi-head self-attention mechanism. Each token's embedding is split into 3 distinct vectors: a query, a key, and a value. Think of it kind of like a filing system. The query asks a question, the key is the label on the file, and the value is the actual content. By splitting these up across multiple heads, the AI runs several attention processes all at once. So one head studies the grammar while another might track the underlying emotion. The absolute crucial takeaway here is that self-attention literally lets tokens talk to each other across a sentence, linking concepts no matter how far apart they are. And to make sure that vital context doesn't just get lost in the incredibly deep layers of the network, transformers use things called residual connections. Think of them as memory shortcuts, ensuring the AI never forgets the start of your prompt by the time it reaches the end. Right, so once the transformer has crunched all that context, it actually has to talk back to us. That brings us to section 3, controlling the AI output, where we balance safety and creativity. So when it's drafting a response, the AI gives raw scores, called logits, to every single possible next word. But how it actually picks the winner depends heavily on a setting called temperature. If you turn the temperature down below 1, the math sharpens. The AI becomes this highly predictable, deterministic robot picking the absolute safest word. But push the temperature above 1 and things get wild. Less likely words enter the mix, and your AI transforms into a highly creative, slightly unpredictable storyteller. But temperature alone isn't enough. We need some guardrails, specifically top K and top P, so the AI doesn't just go completely off the rails. Top K acts as a hard bouncer, cutting off the options at, say, the top 50 most likely words. Top P is a bit more dynamic, keeping a pool of words whose combined probabilities hit a specific percentage. Both of these strategies basically trim away the totally illogical words, giving you that perfect sweet spot of logic and creative diversity. Okay, now that we've totally mapped out the mathematical brain, let's step out of the lab for a minute. Welcome to Section 4, Generative AI in Practice. Because this architecture isn't just writing emails, it's transforming entire industries right now. In gaming, AI is procedurally generating massive, dynamic worlds on the fly. Architects are using it to explore thousands of material constraints in literally mere seconds. It's balancing historical bias with synthetic data and instantly debugging complex code. We're even on the verge of having entirely unscripted, natural voice conversations with characters right inside our video games. But here's the big takeaway from all these capabilities. As this quote perfectly points out, Gen AI is best viewed as a co-creation tool. Humans absolutely remain an essential part of the loop. Whether you're an architect, a coder, or an author, the goal isn't to abdicate your role to a machine. It's about using the AI to overcome writer's block, streamline the tedious stuff, and really amplify your own human creativity. Of course, you can't have a tool this incredibly powerful without some pretty profound complications. Let's move into our final part, Section 5, Risks, Bias, and Ethics, where we look at the very real legal and societal challenges this architecture has triggered. Looking at this impartially, the very mechanics we just broke down lead directly to some serious real-world risks. Because models train on historical data, they can easily amplify existing societal, gender, and racial biases. The sheer depth of these networks turns them into opaque black boxes, causing a massive lack of explainability, which is obviously a dangerous thing in fields like healthcare or finance. Furthermore, the immense data required has triggered massive copyright lawsuits, like the New York Times suing OpenAI. And finally, the incredible realism of the output has fueled a very real wave of deepfakes